Cool. All right. So today's study group mostly will be on data visualization, but first we're going to talk about something pandas related, and that is, when do we know something is destructive or not? Usually when you're trying to figure out whether something is, whether a method is something or not, you would look up the documentation. I know not a great answer, which means you would have to Google everything, but as normal. So some of you might have come across this, and actually the past few 101s I've had a lot of questions about in place equals to true. So as I mentioned yesterday, a lot of the methods are actually not destructive. So for example, if I drop a column in the data frame, it's not actually going to drop the column in the data frame unless I assign it to a variable again. So as an example, let me actually see if I can use this as an example. Let's see, we have this data frame over here. Let's say I want to do car_df, and let's say I just don't want the name column for now. Car_df.drop name. Axis equals to 1 because it's a column, not a row. And if I do that, you can see the output has no name. However, if I take a look at car_df again, it's still there. So that's when it's not destructive. Now, typically, I personally don't like to use the in place equals to true method just because it actually immediately overwrites your old data frame with the new version. If you do something wrong, you end up having to rerun the cells before to get it to the place that you wanted it to be, to reverse the last thing you did. So typically, I would say if you're still testing out things and you're not too sure whether this is really what you want to do, I typically don't do in place equals to true. That said, with coding, and especially in your projects, one big part of that is cleaning up your code, either midway through or when you're done with your project. And while you're cleaning your code, you're already sure that those are the steps you want to take. So to save yourself from reassigning a data frame every single time, you can use the in place equals to true. And by definition, you can see that in place takes a Boolean true or false. If it's false, it'll return a copy. And literally, as you can see here, it returned a copy. Let's see. Let's do it. Yeah, right here. Let's just do the drop. Yeah, it just returned a copy, but it didn't actually change the data frame. I can actually call this car_df2. And now this version will live in car_df2. Oops, what did I just do? There we go. So this version without the name will live in car_df2. But let's say I don't want to keep track of so many different variables, which is very common, totally understandable. What you would do is add in place equals true. So it will do the operation in place, overwrite your data frame immediately. So as an example, let's ignore car_df2. Let's actually keep that. Get rid of this, and do an in place equals to true. So as you can see, part of the node of the documentation also says it returns none. So you don't really see an output here. But if we were to take a look at car_df, we don't have the name anymore. So which methods have this in place equals to true and which don't? You do have to look it up in the documentation, but I think most things do.
Okay, so if I in place equals true, does change it?
Mm-hmm. Yep. So now in place equals to true. I didn't have to reassign anything, and it's here. So basically, two things that are equivalent to each other. This line is equivalent to doing car_df equals to car_df. Let me just take this. And then in place equals to false. By default is false, so you don't actually need to have that there, but just to compare, these two cells are equivalent. So this one does it in place. Immediately the next time when you run car_df, it won't be there. And this reassigns car_df with the one without the name. So these two are equivalent, if that helps.
Okay, yep, thank you.
Cool, awesome. Always good to clarify things like this. All right.
Real quick, when you say they're equivalent, are they equally, I don't know, resource intensive?
Let's see.
Efficient?
Yeah. Let me think. I think so. I think things like this, if there's anything different, it's negligible. I would say, like, if, let's say, you know, instead of doing this, you're keeping a version of every data frame you have. So with every change, let's say I have CardDF 2, CardDF 3, CardDF 4. Obviously, that's more memory intensive. For something when you're like working on a project like this, typically that's fine. But yeah, that's something you want to consider when you're cleaning your code when you're done. And I'll talk about this cleaning process when we get to the projects. But typically in the cleaning process, you would like get rid of all those intermediate data frames that you don't need. And so you'd actually refactor your code or change your code from something like this. And maybe you have like, you know, a bunch of different, maybe you're doing like CardDF2 equals to CardDF.drop. Like maybe now I decide I want to get rid of origin. And then like I'm dropping things one by one and just like, you know, having a data frame there just to keep track. This is something that you would refactor or change once you're done with your project and you're sure that this is the way that you want it. But yeah, this is definitely more memory intensive. Yeah, but in terms of like these two exact lines, because you're just reassigning the variable, you're not actually keeping the old one, same amount of memory to my knowledge. Cool. Anything else maybe related to topic 4 or 5 before we move on? Cool. Let's talk about visualizations.
Excuse me.
Yeah.
When we are reading the files, when we put the variable index underline call equals to 0,
yeah.
What it does exactly?
So let's actually take a look. Read PD, read CSV, and index call. I believe it tells you where to start, but let's take a look. Index columns. So it's basically which columns to use as the index of your data frame. So maybe like in your CSV, sometimes because of the formatting of CSVs, I believe automatically it would give your it would create the index as like what's the word, default index of like numbers, just running numbers. So if I actually were to do index call equals to, I think this might work. We'll see. Index call equals to name. Let's try this out. It automatically makes the index the name. Cool.
Yes, thank you.
You're welcome. Let's not do this for now. But yeah, definitely useful if you know, sometimes it's nice having like instead of a numerical index, a name index. Therefore, you could use like the .loc function on this too. But yeah, all right, let's go back to this. All right, why do we make visualizations? Actually, one of my favorite things, I'm actually going to click onto this link and show you all. But just by looking at data frames, if we were to just do a .describe, you kind of have a bunch of information about like the distribution of each column, right? A lot of people think that this is enough, but it kind of isn't. Here you have like, I think the main ones people look at are mean and standard deviation just to see like, you know, where your data is centered and how varied your data is. One of my favorite things to look at is this. Has anyone heard of the Datasaurus dozen? It's kind of cool because all of these distributions have the same mean and standard deviation across both variables. So each of these have like an X and a Y variable. They all look very different, a lot of really cool shapes. But yeah, they all have the same mean and standard deviation. And without a visualization, there is no way to discern that they are actually very, very different. Because if you were to just take the summary stats of all of these, they're all the same. And yeah, on top of that, they all also have the same correlation, which is wild. So yeah, that is one big reason why visualizations are important. Back to our notebook, let's see. All right, data scientists use visualization in two main ways. One, exploratory data analysis, EDA. EDA is something that we're going to be doing a lot of for every single project. So remember this acronym. EDA is to explore the data that we have to find out more about what we're working with, and we're looking for patterns and relationships. Once we start learning about different models, we'll learn that different models prefer certain kinds of relationships in your data. Some models actually don't allow for kinds of relationships in your data, and you actually end up maybe like taking out some columns or completely changing some columns because of that. And so before we even get into the modeling process, which is a bulk of what we will be doing starting like phase 2, you have to do a lot of EDA to make sure that your data will work well with the model. It'll save you a lot of trouble afterwards just by doing a little bit of EDA. Patterns and relationships, sometimes just by like looking at the relationship between columns is kind of a cool thing. We'll take a look at a bunch of examples later. Another thing we use visualizations for is for explanatory data visualizations. So this is just to like give us more information so that we can start our analysis or start our modeling process. This is really for stakeholders. And our very first project is actually going to be an explanatory data visualization project. We're gonna take the data that we have, and it's going to be kind of messy data, and you're gonna try and make sense of it and maybe turn that into an actionable insight. Saying like, all right, we see this, like imagine like some business presentation and you're like, all right, take a look at this relationship between these variables. Because of this relationship, maybe your business wants to do this. And so you're using visualizations to help back up the points that you want to make. And yeah, exactly, to convey our narratives, our takeaways, and our insights. So 2 main ways, both very, very important. I would say like for this first project, more of a focus on explanatory data visualizations, but for future projects, you'll see that we're gonna do a bunch of EDA. But in our presentations for our projects, we'll actually be using EDVs. EDV is not an actual acronym that we use, but easier to say. Any questions on like why we do visualizations? Cool. All right. So for visualizations, what do we import? In our lessons, we talk about Matplotlib as well as Seaborn. At the very end of this, I'm going to talk about another library that's actually my preferred one, and I'll like talk about the pros and cons of each. So let's start with Matplotlib. For Matplotlib, we always have to import matplotlib.pyplot as PLT. If you just were to import Matplotlib, you would actually have to like manually go into the pyplot subdirectory. So basically always import matplotlib.pyplot, and the alias, as we have with like NumPy and Pandas, is PLT. Pyplot is just Python plot. This line, anything that starts with a %sign, I think is called a magic function. But it basically tells your notebook that, all right, for every Matplotlib graph in this notebook, print the graphs inline. I saw that a few of you were experiencing the issues of the Matplotlib notebook thing not working. To be honest, the notebook thing I think is new because I have actually never used it, and I actually didn't know that Matplotlib can do interactive elements. So for those of you who got it to work, that's awesome. But I'll show you another interactive library that I like a lot more. But cool. We're gonna use our car data frame just to like demonstrate some visualizations. So I've linked the Matplotlib documentation here. It's an okay documentation, I think. I think it's not the clearest, but there's just so many different plots that you can make that I think it's it's a good resource to just see like what different things you can do. Not just with the different kinds of plots, but I'm sure a bunch of you have noticed that there are a bunch of different things that you can customize within Matplotlib. Like for example, let's see, let's look at, I was thinking of title, right? So here we have the title of our graph. Here we have a bunch of things about, let's see, I think there's like a bunch of labels. Yeah, so the limits of your axis, your labels, your however many ticks you want, like those tiny little lines along the axis, a lot of things that you can customize with Matplotlib, and that is one of the pros of Matplotlib. Very, very customizable. All right, some common visualizations that you might want to use: line plots, scatter plots, bar graphs, both vertical and horizontal, these are just horizontal and vertical lines. Very useful if you want to like compare, for example, like your bar graph to some sort of benchmark. So let's say you have like a bunch of different bars for like, I don't know, different grades of chocolate. And then you have like some universally known like average, and then you would compare that way. Same with a vertical line. Maybe if you have like, literally if you were to flip everything 90 degrees and you have all of your bars going sideways, a vertical line as your benchmark. And then stack plot. Stack plot is, actually let's Google what a stack plot is. It's basically bar graphs, but let's see if they have examples here. There we go. Basically stacked on top of each other. There's so many kinds of plots. One thing that I found very funny is that while like browsing on Glassdoor, I found out that there's a job called data visualization consultant, and their job is to consult on graphs, and they make about as much money as data scientists do, which I felt like was a little unfair because they talk about pictures, but you know, that's fine. Life is not fair. But anyways, the figuring out what the best visualization is to use is, to be honest, not something that is always very intuitive, to be honest. Sometimes you try and visualize something and you realize, hey, you know, it's not very clear what the relationship I'm trying to get at here. And so you really have to trial and error. A good Google sometimes will give you like some solid options. And so, yeah, it's one of the, again, one of the more artistic parts of data science, where you're figuring out what's the best way to present what I want to get at. So there's that. It is very, very subjective, especially I know like for some reason, data scientists hate pie charts. I don't know if you've come across any readings, but data scientists really don't like pie charts. I have nothing against pie charts. I think it's a very clear way to see like proportions, especially if you don't have that many groups of things. But yeah, data scientists for some reason really don't like pie charts. All right, let's talk a little bit about the syntax. I sort of like to think about Matplotlib syntax as like building blocks of which like you build upon the thing that's going to end up being your full graph. So there are different levels of plots, and we'll talk about the most simple one first before getting into where I think a lot of people get confused with like big and X and subplots. So if you're just doing one single graph, this is the syntax you can use. First, you start with the thing that you're plotting. And here I was just starting with a scatter plot. And as you can see here, we have our scatter plot. Nothing is labeled, but we'll get to that in a little bit. And yeah, we're basically telling it which columns of data from our data frame to use. That's another thing why data frames are so great, that a lot of other libraries can understand series and data frames. So yeah, that is step one. And I sort of think of it as like building blocks. If you have all your code in one cell or write one after another, it knows what you're adding to. What's happening in the backend, I honestly am not too sure what's going on back there, but as long as everything is in order and preferably in the same cell, it will all come together in one single graph. Cool. So I'm just adding the bits one by one. First, I would like a title of this graph because I have no idea what the scatter plot's talking about. So here, plot.title, relationship between displacement and horsepower. And once we have that, you see that we have this title over here. Next, the X and Y labels. And by the way, the shortcut for like commenting, I don't know if I mentioned, is command ? Or control ? Any row that's highlighted will automatically comment and uncomment. I think that's just really nifty to have. So labels, displacement, and horsepower. And there we go. We have displacement and horsepower. Now I know which one is which. Now, legend. This graph legend, not super important, but you know, each one is a car. That's some information. And then finally, plot.show. Plot.show, not necessary, but as you can see, I just get really annoyed at this output here. And so it's kind of similar where, remember when y'all were doing like a group by, and if you do a group by without an aggregation, it sort of gives you like this, there's this object here. For example, let's actually do it really quickly. Let's do like a car df.group by, and let's group by, I don't know, origin for now. If I don't give it like an aggregation, it's still at some like intermediate point where it doesn't really know what to output, but it's telling you that this is where we're at right now. So kind of similar. The last thing that was called out here was the legend. And so just to like not have that, and basically to tell it, all right, this is how we want to output our graph so far. Just having a plot.show, you don't have that random line of code there. But that's literally what the show does.
When can you use a semicolon to do that instead?
You mean like a semicolon like right here, or
Yeah.
You mean like without needing a plot.show?
Yeah, I thought I saw some of like the subplots were doing that. Yeah.
This is the first I'm learning of this, to be honest. But yeah, cool. I guess you could do that as well. Semicolons are not a very Pythonic thing to my knowledge, but great. Yeah, wow. I wish I knew that. But cool. Yeah, I guess you can use a semicolon. I'm guessing it does the same thing in the back end to basically like finish off your graphing lines of code. Cool. All right. So this is just like the simplest way to create a graph. You just have one item and then you're just adding on to it. Questions before I move on to subplots? Cool. Subplots is where I think it gets a little bit more tricky. And so there are a bunch of things that are being declared here that I feel like not the best choice of words, but that's what they are. So some terminology, you have figure and axes. So figure actually refers to the overall image space. So let's say you want to have a graph that has, I don't know, like 20 subplots. All 20 subplots are part of the big figure. And then each subplot is an axis. I don't think it's a great word for it because axes is also like the y and the x axis. But yeah, each axis with an E is each individual graph inside a figure. So that's kind of like the hierarchy there. So let's run this block of code and we'll like break this down. So here I have some histograms. So what we first do is we actually have to assign the figure to a variable just so we can update features of the figure as and when needed. So if we have just plot.figure, it'll be a little bit harder to like add the subplots to it if it didn't already belong to a variable. If that makes sense. So plot.figure is just an empty figure. Actually, we just start from the very beginning. Plot.figure will have some figure and has 0 axes, so nothing's being output. This second line is just to show that, all right, anything that's fig dot is adding things to the entire figure. So this is, I found through looking up documentation, that you can have the title for the entire figure is subtitle. And my subtitle will be some histograms. And again, I'm not really showing anything. Actually, maybe if we do this, something will show. Nah, just kidding. All right. So within each figure, we're going to add some subplots. There are multiple ways to do this. If you have like maybe like a single digit number of subplots, you could possibly do that. I would say not more than like 6, because you would have to do like each one individually here. And there's another example that I'll talk through where they do it in a loop. But you're going to add subplots one by one in this example. So the variable name that's usually used for subplots is ax, short for axes. And what these numbers mean, I personally don't think is the most intuitive way to do it, but it means row 1, you're gonna have 1 row, 2 columns, and it's the first graph in that grid. So that 1 to 1, that's what it is. Your whole figure is going to have 1 row, 2 columns, and it's the first graph of that grid. Similarly for the second one, 1 row, 2 columns, and it's the second graph. So that's how that breaks down. So that's adding the subplot. And again, easier to give it a variable just because you can add specific things to each variable. So for this first one, I'm plotting a histogram of the weight. And then in ax.set, I'm giving it the x and y labels. So annoying, inconsistent thing about Matplotlib is that when you're defining attributes of a figure, not always the same when you're defining the attributes of an axis. So remember how before when we had this figure, technically, we would do .x label and .y label. Not the same when you're doing it for an axis. So that is something that, honestly, I look up the documentation every time I'm creating any graph that is like more complicated than like a single thing. So something to look up for sure.
Is that the same thing as set like X label, for example, but you can just do X and Y in one line?
Yeah, so x.set, let me see if I can actually find the documentation for here. So x.set has a bunch of, this is not what I'm looking for. I think there is a page of documentation somewhere. I think it's this one. X.set, there's actually a really long list of things that you can put into x.set. So this is an example, but here you see I can put like X label, Y label, X limits, Y limits. There's a really long list of things that you can put in the set method to set things for an axis. Because I believe that if I were to do x.y label and x.x label, it's not going to work the same way. So let me just test that out, just to check. Yeah, because this is the exact format that actually worked for this. But wait, that's not how I did it. Like this. And you can see here, axis subplot has no attribute X label. So it is different for when you're defining things for a figure and for an axis. So something to just keep in mind of. I think this is one of the biggest reasons why most students go towards Seaborn. But anyways, back to this, we're doing the same thing here, where we're doing the one for the first subplot and all the stuff for the second subplot. And when we have this here, we have this nicely put here. Cool. I'd say this for any graph that you're doing that's more complicated than this, you're very likely going to have to look up documentation, because there's no way you will remember all of these arguments. Unless you end up doing graphs all the time and you remember, that's great. Cool. Any questions before I move on to Seaborn? One other way that kind of makes it, I don't know, easier or harder for me to understand how Matplotlib works, you can sort of think of each fig and each ax as an object. Object is kind of another, I guess it might not make as much sense now, but I sort of think of each of these as objects and these as attributes that we're updating of the object. Yeah. Cool. Let's move on to Seaborn. Seaborn is what most students prefer because 1, less lines of code to write, and 2, by default, Seaborn looks nicer. So the alias for Seaborn is SNS. I'm honestly not too sure why SNS, but for this purpose, let's randomly create some data. So here you can see I'm doing NumPy random normal. I've gotten a few questions about the NumPy random, the random library, the random module within the NumPy library. Basically what it's doing here is it's pulling a size 20 by 10 array of numbers randomly from a normal distribution, centered at 0, standard deviation of 1. And for each of them, I'm going to add some random range between 0 and 5. No, wait, sorry, between 0 and 10, and then dividing it by 2. So let me just output this and we can see. Let's look at what the data is. All right, a little bit confusing, but imagine this is I have 20 rows of 10, basically. And what I'm doing is for each of these is a random number pulled from the normal distribution, which means very likely to be centered around 0, can be positive or negative. Other facts about the normal distribution is like 99% of the time, the values will be between negative and positive 3. So that's kind of the distribution we're looking at, and higher chance that it will be closer to 0. So each of these numbers is a random number from the normal distribution, plus,
And, I'm sorry, and the total should be 10, right?
not exactly, not exactly.
So
Can you say that again?
what is 10 mean? Like 20 and 10?
Oh, yeah. So there is 20 rows of 10 values.
10, okay.
Yeah. So each of these lists has 10 values, and there is 20 of these lists.
Oh, got it.
Yeah, so that's the shape of that normal array, I guess. And so each of these numbers is randomly drawn from the normal distribution. We're gonna add a range. Oh, I remember now. For each of these numbers, we're gonna add like a range 10, which means we're gonna add 0, add 1, add 2, add 3, add 4, add 5, add 6, add 7, add 8, add 9. I believe that's what's happening. Let me double check. I could be wrong. Yeah. So for each of these, because of broadcasting, we're adding this array to each of these. So that's why each of these, on average, these like numbers at the end of the list are a little higher. And then after that, we're dividing the entire link by 2. So that's just the construction of this normal set of data. But yeah, cool. Questions about this? Awesome. Cool. All right. Something great about Seaborn is there's a lot of pre-built things, like, for example, a Boxplot. Boxplot, something like this, very useful in like making sense of groups of data. So sort of like it automatically does a group by as well. Actually, does it automatically do a group by? If you were to give it data from a data frame, I think it does actually look at group bys. But anyways, it's looking at different groups of data. And so each of these is for each like array of data. But anyways, my point being that that Seaborn already automatically has the code to generate a boxplot. The code to generate a boxplot for Matplotlib is a lot more complicated than this. And boxplot could be something that you might want to use at your project. So if I were to look up Matplotlib boxplot, I believe that let's see if there are any, here. For the boxplot, you can sort of see that it is a little bit more complicated because you would have to define some subplots and do some boxplots. And by default, this is what it looks like, not as pretty with the colors. So that is really why people decide to use Seaborn. And if we look up the Seaborn documentation for a boxplot, it's a lot clearer what you can pass in. So because of that, that's why students typically like to use Seaborn more. A little bit harder to customize specific elements of it because everything's so pre-built. But for our purposes, anything that Seaborn do should be fine. But yeah, you can even feed it in like an entire data frame and plot specific parts of it. I would say my advice to you all when like getting used to doing visualizations, pick your library and then try and do each exercise with the library that you want to use. You don't have to know like all 2 or 3 libraries well, just the one. Questions about that? I personally think that the Seaborn documentation is very, very good. Seaborn is also not my go-to visualization library. I'm actually going to show you really quickly which one mine is. I guess super quick, let's set these there. And this should actually be here. There we go, in the same cell. And then if we just do, is it plot.show? I forget, but never mind. But yeah, Seaborn is a lot more user-friendly. Really quickly, I wanted to show you all the one that I like the best, called Plotly. And recently, actually only about a year and a half ago, they came out with Plotly Express that has made plotting even easier. Not part of the curriculum, but I'm trying to make it happen. What you do, you import Plotly Express as PX. What I really like about this is you can literally feed it in your data frame and it reads from your data frame. So just to like print our data frame here for reference, we have our car data frame here. And let me output this. I really like this because one, it's interactive. The colors are also pretty cool. And things are also easier to update. So for example, here you can see everything just is nested under the plot.scatter. I can tell it what I want on the x-axis, what on the y-axis, and these are actually columns pulled from the data frame. I can take into account one other feature. So each of these colors represent a different origin. So all of these blue dots are origin 1, these pink ones are origin 2, these green ones are origin 3, and you can add a title. So this one has, in my opinion, the best documentation. So the only downside is we have not much curriculum material on it. Some other pros of this is that towards the end of the course, you might want to build dashboards, interactive dashboards, and interactive dashboards are actually built with Plotly. So learning Plotly will make it easier to transition into doing dashboards.
Can we start,
yeah.
if we wanted to do Plotly, could we start just like trying to implement it in our labs and in our project?
Yeah, absolutely, absolutely. I definitely have had students that did their phase 1 projects using Plotly. A little bit more time consuming because you don't have as much practice of it because it's not in the labs. But
Right.
if like that's a decision that you like make right now, and before you get into topic 6 labs, you can start like, you know, looking up documentation and trying to implement like what they're asking you to implement in like Seaborn or Matplotlib in Plotly.
Okay, and then like the working in the industry, is one of these more commonly used than the other, or they're kind of all interchangeable, or
Yeah.
what do
So
companies usually do?
yeah, very interestingly, actually, Seaborn is actually built using Matplotlib. So the backend of Seaborn is actually Matplotlib. They have just like abstracted certain functions so that you don't have to type as many lines. Also, you know how in the pandas, I think topic 4, there was a lab that was like creating visualizations directly from pandas. That by default also uses Matplotlib. You can also change it actually. If you look up pandas plotting backend, you can actually change it to plot with another library, but by default it's Matplotlib. For industry, if you're going into something that requires you to make a lot of visualizations and like continuously run a dashboard, typically you'll be asked to not use any of these as like your presentation format. You would actually be very likely be asked to use something like Tableau or like what's another one? Like what's the other business one?
Like Power BI or something?
Power BI or ClickSense, one of those. And so the skill that you're really trying to get from here is like making plots here for your own purposes of doing like EDA before a project. But if your job is to present data, more than likely it will be in one of their softwares.
Okay, so that's like a whole other, like Tableau, for example, comes up all the time when you look at like job listings. So that's like another platform that just allows for data visualization. And does it have its own language or anything like that, or it's just? Yeah,
Tableau kind of has a little bit of its own language, but for the most part, it's like you import a CSV and you drag and drop like the columns onto like where you want it.
So it's not like heavy like coding or anything.
Yeah, not at all. Not at all.
How the software works. Okay, that makes sense.
I have come across like several people that, especially if it's like a startup, I think, and they're very agnostic on like what technologies you use. I have come across a few of them that actually build their dashboards using Plotly. Plotly is actually built on, if anyone has heard of the library for JavaScript called D3, very, very powerful visualization library. So I have seen like complete dashboards coded in Python, coded using Plotly. So I would say like Matplotlib and Seaborn are great for like, you know, when you're exploring your data for like yourself and maybe within like a data science team. But when you're presenting your data, very often you're like either taking like screenshots and putting them on slides, or like, I would say like this is like the most you would do in terms of like when you're presenting your data to like stakeholders.
So these would be more for like internal purposes.
Yeah, exactly.
Okay, gotcha.
Yeah, very dependent on each company, but for the most part, that's like what I've noticed. Cool. that is actually all I have for you guys. Does anyone have any questions about literally anything? I
Sort
could
of
talk about?
related to that last question, I was wondering, like, if someone ends up having to use R, are any of these similar to what you would use with R?
Let's see. With R, I'm honestly not too familiar. I know that there are I want to say, is it Power BI maybe that like would let you put in R syntax if you had like to make a calculation within their software, but not too much. I'd say like for data scientists that use R are definitely the ones that have gone through like formal like computer science or like higher education, just because R is very, it is typically used in like academia. We will actually come across a little bit of R in the next phase, but no, I don't think I can confidently answer that question, to be honest.
Okay, thanks.
Of course. Anything else?
Can we go through the exercise too?
Oh my gosh, yes, of course, of course. Thanks for reminding me, Chrissy. And we do have that time. Cool. So this is the exercise in, what is this one called? Customizing visualizations with Matplotlib. The thing that I think is pretty tricky about this one are these lines here. So I'll like talk about how that works. So earlier I talked about doing subplots by, you know, defining each axis on its own by doing like the 1, 2, 1 and the 1, 2, 2. There's another way you can do subplots by telling it how many rows and columns. And this is just like the overall figure size. So what dot subplots does, and also I guess I should explain what this means. So when you have fig and axes, sometimes in a dot subplots, you have two outputs. So I don't know how often you come across this, but sometimes you have a function that has two outputs. It usually be like output 1, comma, output 2. And automatically Python knows how to unpack that. So Python knows that it will unpack the first thing being fig and the second thing being axes. And that's just like how the plot.subplot function outputs. So that's the first part to like setting up the whole figure. So with the axes, you know here that we have here, we're creating a figure with 3 rows and 4 columns, and each of these have like a different straight line that is going up with a different gradient. So here you can see this is like a 1 to 1, here's a 1 to 2, down here is like a 1 to 8. But cool. For this, for I in range 1 to 13, because your subplots are 1 to 12, and the way that range works, you tell it where to start, tell it where to not get to. This part is kind of confusing because you have to tell it which row and which column to be in. So these parts, mathematically, if you were to plug in I for different values of I between 1 and 12, you'll sort of see where in the grid it'll land up. So here what we're doing is we're doing a floor division, right? We're doing a floor division of, I guess, I minus 1 divided by 4. So floor division basically means you'll take the quotient, that meaning like, let's say when you do like 4 divided by 3, it goes into 3 goes into 4 once, so the quotient is 1. So in this case, we're dividing by 4. And when you divide 0, 1, 2, and 3 by 4, your floor division result will be 0. So for the first 4 i's, your row, it'll edit row 0. If that makes sense. So the first 4 i's, you'll be doing row 0. The next 4 i's will be like 4, 5, 6, and 7, which will give you a floor division result of 2. So that's how it knows, you know, how to go down this grid. It actually starts with this, this, and then this. With this part, I modulo 4 minus 1, it's actually how it moves through the columns. So what it's doing here, I modulo 4, each time you take I modulo 4, it is the remainder. So 0 modulo, is it 0? Yeah, so it starts at 1. So 1 modulo 4 is 1. And then you're going to minus 1 because it indexes at 0. So technically you'll go 1, 2, 3, 4. The modulo will be 1, 2, 3, and I think 0. Yeah, the modulo will be 1, 2, 3, and 0 because that's the remainder. Minus 1. So it actually becomes 0, 1, 2, minus 1. The minus 1 here works because it's the last column. So last, you can either index at 3 or minus 1. So these, I will say, some complicated math involved. I wouldn't expect someone to come up with this on their own. It's just like interpreting what these are can be kind of confusing sometimes. But that's basically how, that's basically assigning the rows and columns so it knows how to move through the grid. And I'd say if that was still confusing, try plugging in different values of I and literally just outputting these two values and just to see like how they change when you change up I.
I have a quick question. What does it mean when it says the respective subplots over the domain 0 to 10? What's the domain 0 to 10?
Let's see. The respective subplots over the domain 0 to 10. That's a good question. I'm not too sure. I'm thinking probably 0 to 12 is what they mean.
Right, that makes sense if it's 0 to 12 and then they're telling you to plot 12 graphs.
Yeah. Yeah. I'm trying to think, yeah, if they had any other random data. Yeah, no, let's see. X is, what is X? X is just this random information. Yeah, I feel like it might be, I think they mean to say 0 to 12. But yeah, thanks for clarifying. But yeah, so after you've told it where to look up rows and columns, axes already contains like the empty spaces for the 12 graphs. So you just have to tell it where in axes to look at, tell it which row and which column, define the new Y for this, and then you're just plotting that. Did that make sense, Chrissy?
It's still confusing, but
yeah.
I think maybe playing around with it would be helpful. I think it's helpful for me to actually like go through a variable to kind of see how it works, because it just, you know, there's a lot of
for sure
variables in there, and you're like, okay.
Yeah. So like axes is already when you like what's the word? When you not equate, but when you're assigning, right? When you're assigning this to fig and axes is, I kind of like to think of it as like it's already 12 empty slots in the format that you want it.
Mm-hmm.
Therefore, you have to get it to loop through and get the correct row and column numbers, so that, you know, here in this part, each ax is a specific row column of axes, and then you're just plotting that onto the ax. Yeah, it is definitely like something that that does take getting used to.
And
so does that either the Y underscore new, is that pulling down based on, you know, the lines in the instructions, the second bullet?
Ooh, yeah. So yeah, that is doing this part. So it's doing a list comprehension of for each xi in X, and X is a list from 0 to 100. Y would just be that X multiplied by whichever number is here. So now you have the X values, and then you have your Y values, and then you would just plot that.
Okay.
Mm-hmm. I think I kind of heard someone else starting to ask a question.
Yes, I want to ask about the very first line of this code. I don't understand the fig and x is equal to that thing.
Yeah, it's a little, yeah, it is kind of confusing because it's very different from what we saw earlier. But earlier what we were doing, let me actually go back to this. Earlier what we were doing here is we're defining fig first and then defining each axis, right? What we're doing in, which tab is this in? Here. What we're doing here is you can actually do them both at once, especially if you know you're going to do a bunch of subplots. This automatically gives you, actually, let me see if I can, if it's clear in the documentation. So here, let's see. Let's take a look at the returns. So this returns a figure and an array of axes. So because for any graph, you need to have like that figure object because it needs to know like where that big canvas is. And then it also gives you that array of axes. So the reason why you can do like fig comma x, the reason why you can do this is it knows to unpack the two things that this method returns. Did that help?
Yeah, a little bit.
Yeah, it is a little bit confusing. It's kind of similar to saying like, all right, if I define a function, if I shouldn't use the word function, but let's say I define a function that works on a list, shouldn't use the word list either, on a list that returns the sum of the list and the length of the list. I can actually define a function like this. And if I were to, all right, let's just make a list of 1, 2, 3, 4. If I define this list, if I do func on list, you can see that it returns 10 and 4, which is the sum and then the length. Alternatively, what I can do is do this, sum list comma length list equals to this. So because I know that this outputs two different things, I can unpack them, and now sum list will be 10 and then list becomes 4. So I understand that like fig comma x can be kind of confusing, but basically whatever function subplots is has two parts to it. Therefore you do fig comma x, and it automatically will like assign to those variables what the figure is and what the axes are.
Okay, thank you.
You're welcome. I hope that was helpful. This is sometimes also can be a convenient thing if you know that you have a function and like you can output multiple things at once. We'll be using some of this in end of phase 2. Cool. Anything else before we end off?
We don't have to go over it, but I was just curious with Plotly Express, can you do subplots like fairly easily?
I actually don't think so. Let me double check. Express or Plotly subplots. Let's see. Oh, I guess you can. Yeah, nice. In a kind of a similar way as well. One thing to take note of Plotly is, I know I mentioned Plotly Express, but Plotly Express is a part of Plotly. Plotly Express was made specifically to plot with data frames. So when I learned it, it was actually before Plotly Express came out. So there's also Plotly itself that has a lot more options. Again, you can sort of see it is about just as much syntax, but you know, you have that fun interactive element here. I think it makes a little more sense where you like tell it where to plot, but yeah, apparently you can do subplots. I haven't had to do this in a while, but yeah, turns out you can. Anything else?
Yeah, I had a question about Matplotlib. The axes, you can pull them from either like a plot or a figure, like plt.subplot or figure.subplot. They both get you like an axis. I was wondering if there's any difference between like making an axis from the plot or from the figure.
So you're saying that the difference between like doing this subplot from the figure versus versus like doing the subplot from this one, doing the subplot like this?
Yes, exactly.
I mean, the difference is that this, you create all the axes at once, and then the only thing is you would have to iterate through the grid to update each individual graph. Whereas in this example, I'm creating each subplot as I go along.
Well, I guess what I mean is if you can create an axis straight from a plot, why do you need the figure? Like, what is the figure?
Oh, like this part?
Yeah, like why do you have a figure?
Because you're adding this subplot to that figure. This one, you need to know that you're adding this subplot to this specific variable, whereas for this, it's creating it at the same time. So I think it already knows that it's associated. I'm not super clear in the back end, but to my knowledge, this, like, you don't have to like reassociate it.
Okay.
That helps. Because when you're creating this, it already knows that the axes are part of this figure.
All right, thanks.
You're welcome. Cool, we are right at time, but any final questions? Cool, awesome. Tomorrow is gonna be a bit of a 180 because we're gonna talk about SQL. I will say topics 7 and 8, a little bit more on the optional side because it's not gonna be super relevant for our projects, and they are very, very separate, like kind of disjointed topics, but good to know. So I would definitely, like, if you feel like you're a little bit behind on the lessons, focus on 4, 5, 6 for now, and maybe get a little into 7, 8. You can skip if you'd like, but I will still do those study groups. All right. If there's no final questions, I will see you all tomorrow, and if not, at your one-on-ones. Bye, everybody.